start with mole concept then. Chapter 4. Mole concept and stoichiometry. Okay. So numericals are there in this chapter. All of you be ready with your notebook and pen. Correct? Do you have numericals based on percent composition?
Yes, ma'am, we have.
Percent composition is there. So we'll first do the numericals based on percent composition. Okay, just a minute. Okay. Now is it clear, Dhanashri? Is the screen clear now?
Yes, miss.
Okay, so we'll start with the numericals based on percent composition. Please pay attention and please write down everything. Okay, percent composition or percentage composition. Now see, what does this mean is that it tells you about the percent of each element present in the compound. Okay, what does that mean? For example, suppose we take HCl. Okay, this HCl is a compound. Percent composition will tell you the percentage of each element which is present in this compound. It will tell you what is the percentage of hydrogen and what is the percentage of chlorine in HCl. Okay?
Yes, ma'am.
Okay, you all can refer the textbook page 87. Percent composition is what? It is the weight of that element divided by gram molecular weight of that compound. It means, suppose we consider this HCl, weight of hydrogen upon gram molecular weight of HCl, okay, multiplied by 100. Okay, understood?
Yes, ma'am, understood.
Right? So I'll just brush up once again. Percent composition means percentage of each element present in the given compound. Example, if we take HCl, it will tell you about percentage of hydrogen in HCl, percentage of chlorine in HCl. Okay. Then this percent composition, it tells you about how to calculate weight of H, that is atomic mass. Weight means atomic mass of hydrogen upon gram molecular weight of HCl. Can anyone tell me how to find gram molecular weight? It is very easy. H plus Cl. It means atomic mass of hydrogen plus atomic mass of chlorine. That is 36.5. So when we take atomic mass of, we substitute it over here, atomic mass of hydrogen upon gram molecular weight of HCl into 100. Then we get the percent composition of hydrogen in that. Understood?
Yes, ma'am.
Yes, ma'am.
Okay, now see the numerical. I want you all to write it side by side. Okay, write down the numerical. Calculate the percentage by weight of the following.
Ma'am, some noise is coming.
Calculate the percentage by weight. Calculate the percentage by
Ma'am,
weight.
some background noise is coming.
Background noise.
Ma'am, the CPU fan is making noise in the room.
Ma'am, now it's gone.
Ma'am, it is gone now.
Clear now? Is it coming now also?
No,
No,
ma'am.
ma'am.
No, ma'am, it is not come.
Is my voice clear?
Yes, ma'am.
Yes, ma'am.
Okay, so please give the heading. Calculate calculate the calculate the percentage by weight. Calculate the percentage by weight of the following. Calculate the percentage by weight of the following. Okay, now see, we have to calculate the percentage by weight of the following. The first one we are going to see, we have to calculate potassium in potassium dichromate. Okay, we have to find the amount of potassium in potassium dichromate. Now, formula for potassium dichromate is K2Cr2O7. Okay. K atomic mass is 39. Okay. K atomic mass is 39. Chromium atomic mass is 52. Oxygen atomic mass is
60.
Please remember the atomic masses. It is not necessary that every time in your question paper it will be given. So try to remember these. Now first thing what we are going to do is we have to calculate. We will calculate.
Ma'am, again the background noise started.
Again that voice is coming.
Yes.
Yes, miss.
Ma'am, I think it is some wind noise. Or
Ma'am,
something.
Shivam's mic is on, so from his end it is coming.
Shivam, kindly switch off your mic. Shivam,
No, ma'am, his mic is not on.
It is on, you can see.
guys, kindly check your mic, all of you. Okay. So here, first what step we are going to do, calculate the molecular weight. Okay. Now, how we calculate molecular weight? We have to calculate the molecular weight of potassium dichromate. Okay. Pay attention, please. Potassium is two molecules. So it will be 2 into atomic mass of potassium. They are splitting this formula. Plus 2 into atomic mass of chromium. Plus, now oxygen is 7. So 7 into atomic mass of oxygen. Okay. Now, atomic mass of potassium is 39. So 2 into 39 plus 2 into how much is chromium? It is 52. Plus 7 into how much is oxygen? It is 16. So 2 into 39 is
78,
78. Very good. 2 into
104,
104. 7 into 16.
112,
112.
110.
12.
12.
Add all of them. All of you will close your textbooks now, please. Add it.
294.
294. Just a second.
Excuse me, ma'am.
Yes,
Ma'am, do you know about the bifurcation of the syllabus?
yes, I know. I just tell you, we finish this, then I'll tell. Okay?
No, ma'am. We have. So I thought you don't have.
You want to cross check? Just a second, I'll just cross check with you.
Okay, miss.
See, semester one. Now you'll be having a semester one, correct?
Yes, miss.
Yes, remember.
So you'll be having periodic properties, chemical bonding, acid, base, and salt, analytical chemistry, mole concept and stoichiometry, and electrolysis. Okay?
Yes, miss.
Yes, miss.
Yes, ma'am.
Yes, ma'am.
And SEM 2, you will be having metallurgy, study of compounds, and organic chemistry. Is it correct?
Yes, ma'am.
Okay. Yes, coming back to our numerical. Okay, so now this total is 294. Okay, this is the molecular weight of potassium dichromate. Now in this we have to find how much percentage of only potassium. K2Cr2O7 is potassium का percentage कितना है that we have to find. Okay, so how we are going to find what is the atomic mass over here? Two molecules are there. So it is 78. It means that 294 grams of K2Cr2O7, it contains 78 grams of potassium. Okay, then we have to find it in percentage. Whenever we find it in percentage, we always take the standard value as 100 grams. Okay, so it means therefore 100 grams of potassium dichromate will contain,
And that right side of the board is not visible.
okay, will contain how much amount? We take as X. What we do is to cross multiply करो. The term which goes towards, we have to find X. The term that goes towards the X always comes in division. 294 is going towards the X, so it will come in division. And this 78 into 100. This part have all of you understood?
Yes, miss.
Yes, ma'am. Understood.
Now you will divide it. We'll take division by 2. 2 1s are 2. 2 4s are 8. 2 7s are 14. 2 3s are 6. 2 9s are 18. Correct? 2 7s are 14.
Miss by 3.
How much it comes? By 3 you do. Okay. Tell me. 3 1s are 3. 3 3s are 9. 3 4s are 12. 3 9s are 27. Then
Miss, no for the multiplication, I think. Division.
suppose we take my 4 1s are 4. 4 2s are 8.5. 4 2s are 8. 4 5s are 25. Okay. Suppose now by 5 we take 5 2s are 10. Point 5 5s are 25. 5 5s are 25. 5 is 5. Then this is
0.5.
okay 0.52. Divide this 0.5 by 13.
26.
26.5. Correct?
Miss, exactly 26, no?
Yes. No, now it is 26.5. Okay, if this term was less than 5, then
Ma'am, the right side of the board is not visible.
okay. Now see what we are getting is 26.5. Okay, you have to mention 26.53. The reason is that this term, after the point when we write the digit, if it is more than 5 or if it is equal to 5, that time we have to mention it. If it is less than 5, you can write only 26. That is 26%. The 100 means 26% is potassium. Okay?
Yes, miss.
Okay, Aditya. Now we'll see the next sum. Now, we have to find the weight of phosphorus. We have to find the percent composition or percentage by weight of phosphorus in calcium phosphate. So second sum, we have to find the weight of phosphorus, percentage composition of phosphorus in
Ma'am, the screen is blurred.
calcium phosphate. Okay, calcium phosphate is CH3PO4 twice. CH3PO4 twice. So we in this CH3PO4 twice we have to see what is the weight of calcium. Calcium atomic mass is 40. What is of phosphorus?
31.
31. And oxygen it is 16. Atomic masses. Okay, these are atomic mass. Okay, what step I will do now? Any one of you tell?
Ma'am, the molecular weight will find.
Molecular weight.
Find molecular weight of calcium phosphate. So that will be how much? 3 into
3 into 40.
atomic mass of calcium, correct? So 3 into 40
40.
plus 31 plus oxygen is 4. So
4 into 16.
into 16. 3 into 40,
120.
plus 31 plus
64.
64. What is the total?
310.
310 grams. Okay, it means that 310 grams of calcium phosphate contains how much is calcium? 120 grams of calcium. Also, we have to find
Miss, we forgot to write multiply 31
Yes, miss.
Into
31
two.
into 2.
and 64 into 2 again. Because phosphorus and oxygen will be 8 times and
Twice.
31 into 2 because phosphorus is twice and 64. 4 into 16, this also into 2.
Into
So
2.
4 into 2. So how much we get? 120 plus
62
62
and 128.
plus 128.
128. So what is the total?
310.
310.
310 grams. Okay, so 310 grams of this calcium phosphate. We have to find for phosphorus. It contains how much amount of phosphorus? 62,
62
right?
grams.
Okay, it contains 62 grams of phosphorus. So how much will 100 grams of calcium phosphate contain? Again cross. So X will be equal to 100 into 62 upon 310. 0, 0 cancel. 31 into 1. 31 into 2. Is it correct? Correct?
Yes, ma'am.
20% of phosphorus. Yes or no?
Yes,
Correct,
ma'am.
miss.
All of you? I want all of you to close your textbook. Are all your textbooks closed?
Yes, ma'am.
Yes, miss.
Any doubt in these two numericals?
No, miss.
No, ma'am.
Okay, we'll take the next. Write the question. Calculate the mass of nitrogen. Calculate the mass of nitrogen supplied to the soil by 5 kg urea. By 5 kg urea. Okay.
Ma'am, can you repeat
The
once?
mass of nitrogen supplied to the soil by 5 kg of urea. So in this amount of urea, total amount of urea, we have to find how much nitrogen is present. Again, try to remember few formulae, okay? It is not necessary that in your exam formula will be given. So urea formula is CO 2 times NH2. This is okay, or you can write as CO NH2 twice. Okay. Atomic mass of nitrogen is 14, hydrogen is 1, oxygen is how much? 16. What is the atomic mass of carbon? What is the atomic mass of carbon?
Miss 12.
12. Okay. Atomic mass of carbon is 12. So, who will tell me the next step? What we have to do now?
Molecular mass.
Molecular weight.
How are you find? Please see. Molecular weight of urea is this way. 14 plus 2 into 1. Okay. Plus 12 plus 16 plus again 14 plus 2 into 1. So that will be 14 plus 2 plus 12 plus 16 plus 14 and plus 2. Total it is. Tell me the total. Take pairs. When you take pairs, 14 plus 2, 16. 12 plus 16, 28.
28,
16.
16, 32, 28. 60, miss. 60 gram.
Yes, very good. It is 60 grams. Okay. Now total nitrogen, two atoms of nitrogen are here. Each is having atomic mass 14. So therefore, 60 grams of urea contains 14 plus 14, 28. 28 grams of nitrogen. Okay, so how much will now here look at the question properly. It is 5 kg of urea. Okay, so for that 5 kg you will have to convert it into grams. Correct? So what is 1 kg? 1 kg
5,000 grams.
1000 grams.
1000 grams. Here we have how much urea? 5 kg.
5 kg. 5000 grams.
5 multiplied by 1000. So 5 multiplied by 1000 grams contains how much? Understood this point, all of you?
Yes, ma'am.
Yes, ma'am.
Okay, so again we'll cross. So what will be x? X will be equal to 28 into 5 into 1000 upon 60.
60.
So tell me.
90 upon 6.
Okay,
Then
6, 6, 4, 24 point
No, miss, it is not divisible by
4.666 comes. 4.6 into 500. Okay, easy way how we will do 4.6 into 500.
so,
Nothing that
so 466 into 5.
it comes here.
2300, miss.
0.5.
Ma'am, 2333.
Cos 4 into 0, 4 into 0, 4 5 4 into 5,
20.
20. And then 0,
Miss, it is coming 2330.
correct? So how much it is coming?
Miss, mine it is coming 2230.
The voice is not clear.
Ma'am, it is 2333.3.
Yeah?
Ma'am,
Let me
2333.
check what you are saying. Okay, 2333. Fine. Any doubts? Any doubts?
No, ma'am.
No, ma'am.
Take the next sum. Calculate the percentage. Yes, if you get 2, 3, 0, 0, correct. 2, 3, 3. This is important because these terms, these are less than 5. So first two digits are considered when the next are less than 5. So this is correct. If you get 2, 3, 1, 1. See, because when we divided, we are only divided with 4.6. Here you will divide two further numbers. So that's why it is different. So main, if you are getting 23, then it's correct. Okay, all of you?
Yes, miss.
Yes, ma'am.
All of you.
Yes, ma'am.
Okay, next sum. Calculate the percentage of one minute. Calculate the percentage of water of crystallization. Calculate the percentage of water of crystallization in washing soda. In washing soda. Now here, pay attention. This sum is a bit complicated. Please pay attention. We have to calculate the percentage of water of crystallization in washing soda. Washing soda is detergent that we use. It is having pores in it, holes in it. Every detergent molecule has holes in it. So in that pores, how much amount of water is present that we have to find. Okay. Now washing soda, the formula is Na2CO3 dot 10H2. It means,
Ma'am, is it same for all?
yes,
Ma'am, is it same for all the brand? Ma'am, is it same for all the brands, ma'am?
chat.
Ma'am, he's asking that if this formula is same for all the brands.
Yes, washing soda. Yes, it is same slightly Yes, it is same for all. Basic formula remains the same. Now, suppose when we talk about detergents, coloring agent they add. So some of them are white, some of them are blue, some are yellow. They add the perfume in that. So that is the reason why various detergents they have various perfumes. But the basic formula of a detergent is same. That is washing soda Na2CO3.10H2O. That is sodium carbonate having 10 molecules of water in it. Okay.
Yes, ma'am.
Okay, now,
Okay, ma'am.
yeah, coming back to our numerical. So this washing soda, Na2CO3.10H2O. Now, how we are going to split up this? Sodium atomic mass is 23, carbon is 12, oxygen is 16, hydrogen is 1. Now, this dot it indicates plus. Okay, dot means plus. Sodium carbonate plus 10 molecules of water. Now, when we calculate molecular weight of sodium carbonate, it will be 2 into 23 plus 12 plus 3 into 16. Okay, 2 into 23 is 46 plus 12 plus 48. How much it is?
106.
106. Now we have to calculate for water. Water is 2 into 1 plus 16. How much it is? 18.
18.
Correct?
Yes, ma'am.
Yes,
Ma'am,
ma'am.
but those
How many
are
molecules
10
of water are there? There are 10 molecules of water. So what will we do?
180.
Into, yes, very good.
180 grams.
180 grams of water, 160 grams of Na2CO3. Now what we have to do is we have to find the percentage of water that is present in it. So before that,
We have to add it.
Na2CO3.10H2O. What will be molecular weight for this? That will be,
286.
yes, 106. That is molecular weight of sodium carbonate plus 10 molecules of water is 180. So that becomes 280 grams. Okay. So then this 286 grams of washing soda, it contains 180 grams of water. 286 grams of washing soda contains 180 grams of water. So percentage we have to find. So we have to find how much will 100 grams of washing soda contain. Okay, how much will 100 grams of washing soda contain? So again cross multiply. X will be equal to 180 into 100 upon 286. So find it out. Times by 18, 0, 3, 4, 12, 7, 21.
Miss, if we divide by 12, it will give repetitive.
How much you are getting?
Ma'am, 62.93.
Yes, we get 62.93.
93, ma'am, 93.
Yes, ma'am, I got the same.
Yes, ma'am. Same here.
Okay. Now I'll give you one sum. Total calculation you all will do and you tell me what is the final answer. All of you, I'm going to ask each one of you. I'm going to take your names and ask. Okay. Write down.
Ma'am, just a minute, ma'am, just a minute.
Yes, ma'am.
Okay, write down. Calculate the percentage of calculate the percentage of pure iron. Calculate the percentage of pure iron, PY. Calculate the percentage of pure iron in 10 kg in 10 kg of in 10 kg of iron free oxide in 10 kg of iron free oxide. Formula is Fe2O3.
Ma'am, repeat the formula, please.
Fe2O3. This is iron free oxide. Fe2O3 of 80% purity of 80% purity. Atomic masses. Fe is 56, oxygen is 16. Fe is 56, oxygen is 16. Solve and tell me directly the final answer. Solve fast. Yes, who is telling? What is the first step that we'll be doing?
Ma'am, the molecular weight of.
Yes.
Which is 160.
Molecular weight of Fe2O3. So that will be 2 into 56 plus 3 into
16.
how much we get?
160.
160.
160. Very good. What is the next step? Okay. Next step is what?
Means we have to find the pure iron.
This is Fe2O3. Na?
Yes, miss.
So it means 160 grams of Fe2O3 contains. You have to find for iron. How much iron it is containing? 2 into 56 is 112 grams of iron. Right?
Again, yes.
Yes, ma'am.
Yes, miss.
80% is given. Okay. 80% is what? 80 upon 100. Correct? 8 upon 10 is 0.8. Okay. Now, this we have to find what is the question. Please see. Percentage purity of iron is 10 kg of iron. How much iron is there? 10 kg. How we are going to convert it into grams? 10 into 1000 grams. So that becomes 10,000 grams. So percentage purity of iron is 80%. So we need to find the grams of iron in that. So that will be 0.8 multiplied by this 10,000, which comes out to be how much? How much it will be?
8,000 grams.
8,000.
8,000. Very good.
1000
That
gram,
is
miss.
8,000 grams of pure iron. 80% pure iron means 8,000 grams of pure iron. It is present in 10 kg of iron oxide. So here we are taking 8,000 grams. Okay, so how much will be present in 8,000 grams of Fe2O3 contains X? Right, so it will be what? It will be X is equals to 112 into 8,000 upon 160.
5,600.
How much? 56.
5600.
5,600 grams is equal to how much kg?
5.6 kg.
Yes. This 5,600 grams, when we have to convert it into kg, 5,600 divided by 1,000, because 1 kg is 1,000 grams. 1 kg 1,000 grams. So when we have to convert kg into grams, we multiply by 1,000. When we have to convert grams into kg, we divide it by 1,000. 0, 0, 0, 0 cancel.
5.6 kg.
That becomes 5.6 kg. Correct? Now, one more step is there. We have to find percentage purity of iron. So, percentage purity of iron will be how much grams of iron we have got? 5.6. Correct? 5.6. We have to find it in how much? We have to find it in 10. So, 5.6 upon 10.
Divided by 10 into 100. 56% of pure iron.
Weight of the element, total gram molecular weight, that is 10 kg. Percentage find करना है, that's why multiply by 100.
I'm into the 56%.
56%.
56%.
So we get 56% of pure iron. Is there anyone who has doubt in this numerical? All the conversions have you all understood?
Yes, miss.
Yes, ma'am.
Understood.
Very good. If you have doubt, please don't hesitate to ask. Okay, we still have time. We still have 5 minutes. So I think we can complete one numerical on that so that next time we can start with empirical formula. Write down the question. See why you have to write the question, because in exam question will come. Once you understand the question, it becomes easy for you to solve the numerical. Okay, that's why. Write down the question. Calculate the number of molecules of water of crystallization in copper sulfate crystals, in copper sulfate crystals, if 10 grams of if 10 grams of hydrous copper sulfate, if 10 grams of hydrous copper sulfate crystal gives 6.4 grams of gives 6.4 grams of anhydrous copper sulfate on heating. Anhydrous copper sulfate on heating.
Miss, can you please repeat the last part of the question?
Yes?
Miss, can you please repeat the last part of the question?
Yes, I will repeat. If 10 grams of hydrous copper sulfate crystals, if 10 grams of hydrous copper sulfate crystals gives 6.4 grams of anhydrous copper sulfate, 6.4 grams of anhydrous copper sulfate on heating. Now see, we have copper sulfate, okay? Copper sulfate dot XH2O. Okay, copper sulfate, this is water of crystallization, similar to the formula that we have seen for washing soda. Washing soda was Na2CO3 dot 10H2O. It means washing soda has 10 molecules of water in it. We have to find how much amount of water is present in copper sulfate. Okay, now here we have two types of copper sulfate. One is hydrous, one is anhydrous. Okay, hydrous copper sulfate means the copper sulfate that contains water. Now this copper sulfate contains water. When you heat it, water will get evaporated, only copper sulfate will remain. So that becomes anhydrous copper sulfate. Anhydrous means which does not have water, and hydrous means which has water. Okay. Now, suppose there is 10 grams of hydrous copper sulfate. So 10 grams of hydrous CuSO4 is there. Okay, when you heat this, water will get evaporated, only copper sulfate will remain, which will give us 6.4 grams of anhydrous copper sulfate, which gives us 6.4 grams of anhydrous copper sulfate. So therefore, we have to find mass of X molecules of water. That is how much? 10 minus 6.4.
6.4.
It will be
3.6. 3.6.
6. Very good. So 3.6. So this much amount of water is evaporated. 10 because 10 grams of hydrous is there, minus this much amount of copper sulfate is there. So remaining is water. Okay, then we will calculate the molecular weight of CuSO4. Okay, copper atomic mass is how much? 64. Copper is 64, sulfur is 32, oxygen is 16. Okay, so 64 plus 32 plus 4 into 16. 64 plus 32 plus 64. How much we get? Molecular weight of CuSO4?
160.
much?
160.
Similarly, molecular weight of water will be 2 into 1 plus 16. 2 into 1 plus 16, that is 18 grams of water. Okay. So then, what we have to find is the molecules of water that are present. So therefore, molecular mass of water upon mass of anhydrous. Anhydrous means which does not contain water. Anhydrous copper sulfate. Okay, mass of water is how much? 18. X we are continuing. Okay, this X upon mass of anhydrous copper sulfate. This is mass of anhydrous copper sulfate. Only copper sulfate is there. There is no water. That is how much? 160. Okay. When we calculated this, how much we had got? Water was 3.6. Copper sulfate was 6.4. Correct? So when we calculate this X over here, can you see? When we calculate this X over here,
This
it
will
will
cross multiply.
this term is with X. Okay, anything which goes towards X will come in division. Always remember that. So it will be 18 into 6.4 at the denominator upon these two terms, that is 3.6 into 160 will at the numerator. So when you calculate all this, 18 1 18 0.2. Okay.
5. Miss, the answer is 5.
How much we get? 5.
Five,
Correct.
Miss. Answer is 5.
5 molecules. Understood, all of you?
Yes,
Have all
Miss.
of you understood?
Yes, miss.
Yes, ma'am.
At homework, in homework you are going to resolve all these numericals, so that if you have any doubt, you can ask me in the next class. Okay?
Yes, ma'am.
Yes, miss.